Welcome back. Okay, if you've been messing around with AI coding agents lately, you've probably had that exact moment of absolute panic, right? The one where you think, wait, did it just execute a random script directly on my host machine? Yeah, it's terrifying. Today, we're unpacking Docker Sandboxes. These essentially act as the ultimate secure playground for your AI. So if you want to let these models write, test, and execute code without totally nuking your own laptop, well, you're in the exact right place. All right, here's our roadmap for this explainer. We're going to start by meeting Docker Sandboxes, then compare templates versus kits, look at running the Docker agent, dive into Git workflows and branching, figure out how to access sandbox services, and finally, we'll wrap up with some absolutely crucial workspace trust and security practices. Let's get right into it. So kicking things off with part 1, meet Docker Sandboxes, the foundations. To put it simply, a Docker sandbox provides this perfectly isolated, secure layer between your actual host machine and, well, whatever the AI is trying to build or break. Think of it like a blast shield. The Docker agent, on the other hand, is the official active assistant operating right inside that secure space. And here's why this matters so much. This agent is incredibly capable. It can use external tools, it can install system dependencies with root access, and it can even run its own containers using its own private Docker daemon. Literally, it's Docker inception, Docker inside Docker. And the best part? All this heavy lifting happens without cluttering up or compromising your actual host system. Now, what's fantastic about this setup is that you aren't locked into a single AI brain. Avoiding vendor lock-in is huge right now, and the agent supports a ton of LLM providers. We're talking OpenAI, Anthropic, Google, xAI, Nebius, and Mistral. Once you inject your credentials, whether you do that through securely stored secrets or just simple environment variables, the agent automatically detects them. From there, it routes your requests to your chosen provider seamlessly. You can literally swap models on the fly depending on what exactly you're trying to accomplish that day. Moving right along to part 2, templates versus kits, and how we actually customize these environments. Docker gives us 2 primary ways to craft these environments: templates and kits. Think of templates as the heavy machinery. They're these highly reusable base images where you pre-install all your system packages and massive language toolchains to ensure a super fast startup. For instance, a template is where you'd bake in a massive Python environment with PyTorch. Kits, which are actually in an experimental phase right now, are the declarative, lightweight YAML artifacts layered on top of that base. The kit is where you toss in a quick API key or a really specific runtime config just for that afternoon's run. What's really compelling here is how this maps your specific goal directly to the right tool. If you need to pre-install heavy tools or capture a snapshot of a running sandbox to share with someone, you reach for a template. But if you just need to add a credential or define a brand new agent from scratch on the fly, you use a kit. In a real-world scenario, a senior dev might spend the time setting up one heavy, standardized template for the whole team, while the junior devs just spin up thin, flexible kits on top of it for their specific daily tasks. It's a brilliant workflow. All right, part 3, running the Docker agent. This is all about action and execution. This is where the magic actually happens. By simply running the command sbx run Docker agent, you instantly spin up a sandbox attached to your current project directory. It essentially uses your current folder as its default workspace. But here's the wild part. It runs the agent without approval prompts by default. It just immediately gets to work on whatever task you gave it. It's totally frictionless, which is a massive game changer for productivity. But honestly, it's also a little intimidating when you see it start firing off commands all on its own. Thankfully, you aren't just flying blind here. Running the sbx command without any subcommands actually opens up what is essentially your mission control. It's a live, interactive terminal dashboard. From here, you can monitor the live status, CPU, and memory usage across all your running sandboxes. You get total visibility. You can start or stop them, jump directly into a shell to manually inspect things, and even manage network rules through a dedicated governance panel. It really makes you feel completely in charge of the whole shebang. Okay, let's switch gears a bit. Part 4, Git workflows and branching for managing code modifications. So by default, the agent edits your working tree directly, exactly like you would if you were typing in a normal terminal. But think about what happens if you spin up multiple agents to tackle different features simultaneously. If you give them all default direct access, they might end up fighting over the exact same main.py file, rewriting each other's functions, and creating a massive headache for you to untangle. Which, of course, leads us to a very elegant solution. And that clever solution is branch mode. This completely isolates the agent's work. Instead of letting the AI mess around with your active, unsaved files, the agent gets its own separate working directory, a Git work tree, and its own specific branch. The real magic is that this is all safely tucked away under a hidden .sbx/directory right inside your project root. It gives the AI a safe haven to experiment and break things without ever touching your pristine main branch or your current working state. Getting this running is incredibly straightforward. You just execute sbx run -branch auto, and the CLI generates the branch and work tree for you automatically. When the AI is done, you use Git work tree list to easily find, review, and optionally merge the agent's isolated work. Oh, and here is a massive pro tip. Remember to add the .sbx/directory to your global or project git ignore file. That single step gives you total peace of mind, ensuring these isolated agent work trees don't constantly clutter up your Git status while the AI just churns away in the background. Moving on to part 5, accessing sandbox services. Let's talk about bridging that network gap. Okay, so picture this. Your agent just built a brilliant new web app inside the sandbox, but there's a catch. Because sandboxes are completely air-gapped and network isolated by default, your local browser cannot reach a server running inside one. It's a feature, not a bug. You have to explicitly drill a hole to see what the agent actually built. And you do this using the sbx ports command to forward traffic from your host machine into the running sandbox. It operates very similarly to how you would publish ports in standard Docker. Now, pay close attention here because this is one of those frustrating gotchas that will literally cost you 3 hours of debugging if you don't know it. Most development servers, by default, listen on localhost or 127.0.0.1. But a service listening on localhost inside the sandbox will not be reachable from your host machine, even if you publish the port correctly. You absolutely must configure your dev server to bind to 0.0.0.0 inside the sandbox to expose it to the network bridge. Seriously, write that one down. On the flip side, what if the agent inside the sandbox needs to reach out to a database or a local API running on your host machine? Well, it can't just call localhost for that either, because localhost to the agent is just its own sandbox. Instead, it must use this specific magic key hostname, host.docker.internal. But Docker doesn't stop there. Because of the strict security model, you also have to pair this with the correct network policy allow list to explicitly permit that connection. It's a belts and suspenders approach to security, making sure absolutely nothing talks to your host without explicit permission. And finally, part 6, workspace trust and the crucial human guardrails. We absolutely must address the elephant in the room when it comes to handing your codebase over to an AI. Just look at this quote from the documentation. It really highlights the double-edged sword of this whole tool. The agent has full access to the workspace directory without prompting. Yikes, right? While the sandbox beautifully protects your host system's OS, inside the primary workspace directory that you mounted, the agent has full unrestricted control. With the default direct mount, it can create, modify, or delete any file in your project instantly. Because of that unrestricted access, you absolutely must adopt a strict threat model. You need to review certain high-risk files if an agent has been let loose in your repository. We're talking about things like Git hooks, CI configurations, build files like makefiles or package.json, and IDE task configs. Let's make this visceral for a second. If the AI accidentally hallucinates a weird malicious script into your .git/hooks folder, the moment you type git commit, you've accidentally executed that code yourself. These files execute automatically, triggered by normal everyday developer habits, so they need extreme scrutiny. So the really big takeaway here is this. Branch mode is a workflow convenience. It is not a security boundary. Even if the agent is working in an isolated work tree on a completely separate branch, it still mounts the full repository. Therefore, every single modification it makes must be treated exactly like an untrusted pull request from a random stranger on the internet. You wouldn't blind merge code from an anonymous user, and you definitely shouldn't blind merge code from your AI agent either. You review it before you merge it, period. As we wrap up this explainer, I want to leave you with one final thought. Your AI agent inside a Docker sandbox is incredibly fast, it's highly capable, and it brilliantly keeps your core machine safe from errant package installs. The sandbox protects the machine, but who protects the codebase? Well, you do. You, the developer, are still ultimately responsible for the integrity of what gets shipped. Keep experimenting, keep building, but always, always verify. Thanks so much for learning with me today, and I'll see you in the next one.